Kate decided to make some money by drawing portraits at Applefest. The graph below shows the relationship between the number of portraits she draws and the amount of time in hours she needs to draw the portraits. So let's take a look at this graph. Before we do, as a reminder, the x-axis is the horizontal axis, so this one down here is the x-axis, and then the y-axis is the vertical axis. So the one going up and down is the y-axis. Also, and this is important to remember, ordered pairs are always written x first, then y in parentheses. Yes, you need to write the parentheses and the comma. All right, so here's Kate's Applefest portraits. If I take a look at the graph along the x-axis, the time spent drawing portraits, that's listed as t. So that means that t is going to be my independent variable. All right, x is always my independent variable. In this case, it's t. T and x are interchangeable in that sense in this particular problem. And my y-axis always represents my dependent variable. So the independent variable will always go along the x-axis, and the dependent variable will always go along the y-axis. So in this case, y and n represent the same thing. So the number of portraits Kate successfully draws depends on the amount of time she spends drawing portraits. Or in other words, she is able to control the amount of time she puts into drawing portraits, and that will affect how many she is able to draw. Take a look at number 1. For each ordered pair, write a sentence explaining what it means. So let's start this together, and then I'd like you to try to finish it on your own. All right, so my first ordered pair that I say is 4, 6. So to find 4, 6 on my graph, I'll go to 4 on the x-axis because x comes first, and 6 on the y-axis, and here's my point. So what does that point mean? That's what I want you to figure out. So what I'm going to ask you to do, please, is pause the video right now and figure out what that point represents in terms of Kate and the drawings and the portraits that she's drawing at Applefest. So please pause the video right now and answer part A. Let's take a look at A. So A, we're talking about the point 4, 6. So what that tells us, our time spent drawing portraits, which let's assume that's measured in hours and not minutes, because 4 minutes for 6 portraits would be pretty amazing. Our time is 4, and our number of portraits is 6. So in English, what this means is in 4 hours, Kate can draw 6 portraits. Please, at this time, if you haven't already done so, pause the video and watch and answer B, C, and D. All right? When you're done answering those, turn the video back on to check your answers. All right? So please pause the video right now. B describes the point 6, 9. So here's 6. It matches up with 9 on the y-axis. And there's my point 6, 9. What that point 6, 9 tells me is that in 6 hours, that's our time, in 6 hours, Kate can draw 9 portraits. For part C, we've got 2 hours and 3 portraits. I can look at this on the graph as well, and in fact, it's always a good idea to pair our ordered pairs with points on the graph so that we have a visual that represents what we're doing. But I don't technically need to. I notice the pattern every time here. The first value, x, represents the number of hours I spent, or Kate spent, and the second value, y, represents the number of portraits Kate drew. So in 2 hours, Kate draws, or can draw, 3 portraits.
Ananya Prasad to the main office, please.
Sorry about that announcement. All right, let's go ahead and take a look at D. D says 1, 1.5. So let's look here. 1, 1.5. That represents how much Kate can draw in 1 hour. So in 1 hour, Kate can draw 1.5 portraits. Even though this is a fraction, that's helpful for us because that represents that the unit rate is 1.5. So the unit rate, or constant of proportionality, is 1.5. So every hour, she's drawing 1.5 portraits. Okay, so you've got a lot of information here. What I'm going to ask you to do is pause the video and take a look at number 2. Number 2 says, write at least 3 equations using t and n to relate the number of portraits drawn to the time spending portraits. I gave you the format for one equation yesterday. Here you're asked to use t and n. So I want to remind you, looking up at our graph, that we said that n was the same as y, and we said that t was the same as x. Pause the video right now and see if you can come up with at least one equation to represent this situation. I told you yesterday that we could represent any proportional relationship by writing y equals k, which is our constant of proportionality, times x. But now we're switching things up a bit because we said y is n and x is t. So I'm changing all your letters on you here. We should still be able to write an equation. If I was using this y equals kx form, I would be writing y equals, and I said that k, my unit rate, my constant of proportionality, is 1.5. So I'm going to say 1.5 and then x. But I was asked to use t and n. So let's just change that. Every time I have a y, I'm going to put an n there. Every time I have an x, I'm going to put a t there. So y becomes n. My 1.5 stays. And t becomes x. So I get y, or n equals 1.5 times t. I could adjust this equation in a couple ways. I'm asked to come up with 3 equations. So another way that I could write this is I could solve for t. So if I want t by itself here, I could take this equation and divide both sides by 1.5. That would give me t equals t equals n divided by 1.5. If I wanted my variables on the same side, I could take my original equation and divide both sides by t. So I could end up with 1.5 equals n divided by t. By no means are these the only ways I could represent this equation. There are plenty more ways I could represent this equation, and you guys know that because we've worked with equivalent expressions. For now, please make sure that you have at least this version written down. If your other two don't match but mean the same thing, you're fine. If not, please change them so they match mine. Take a look at number 3. What is the constant of proportionality? Well, we've already figured out the unit rate, and I've discussed the answer to this question. So I'd like you to answer number 3 totally on your own. Once you've done this, please move on to the video on independent and dependent variables.